So in a previous video, we spoke about the fact that in order for two triangles to be congruent, we have to have congruent sides. So all sides of the triangle would have to be congruent to all sides of the other triangle, and congruent angles. All right, we also spoke about the fact that you don't have to check every single side and every single angle for congruence. You can prove that two triangles are congruent by checking the sides, all three sides, or you can check two sides and the angle between, or you can check angle, angle, side. So all of these situations will prove that two triangles are congruent. And finally, the one that we're going to do in this video is check to see, or use a proof to see if two triangles are congruent by looking at their angle, or two angles, and the side that is included. So if we see angle, side, angle, so two sides, and the angle between is corresponding and congruent to two sides, and the angle between on another triangle, that would mean that these two triangles are congruent. So let's take a look at a proof using this guy right here. Okay, so now we're ready to start our two-column proof. And so in a two-column proof, we start off with our statement column. And we have to give reasons for every statement that we make. All right, so our first statement is going to be something that is given. So we were given that QS bisects angle PQR. And we can write that down again because we were given this information. So that's our first thing that was given. All right, we were given something else, but before we move on to the next thing given, there is something important about why they gave this to us. Well, QS bisects angle PQR. So this is a bisector right here for this angle, which means that it cuts this angle directly in half. Otherwise saying, PQS, this angle here, is going to be congruent to RQS, this angle here. That's because of the definition of a bisector, an angle bisector. So we can write that down as a statement. Angle PQS is congruent to angle RQS. And again, the reason for this is because we have an angle bisector. So the definition of an angle bisector allows us to do that. All right, what comes next? All right, so there is actually another piece of given information right here. So we have that angle PSQ is congruent to angle RSQ. And again, the only reason that I know this is because this information is given. Let's actually put some markers up in our figure here, so we know that, and we also know what we just saw, PSQ. So PSQ is here, and that is congruent to RSQ, which is here. All right, so what else do we have here? Well, there is a side that is a part of both of these triangles. That blue side here is a part of both triangles. So because of that, it is equal or congruent to each other. So that is our fourth point here, or fourth statement, says that QS is congruent to QS. Now it sounds like I'm stating the obvious, but I really do need to put that down because that is one of the sides of each of our triangles. So the reason that we know QS is congruent to QS is because of the, let's put that there, because of the reflexive property of congruence. So let's write that down. All right. So now what do we have? Well, we have here an angle. On the triangle at the top, we have the angle here, side, and then an angle. At the triangle, on the triangle at the bottom, we have angle, side, and angle. And that is enough to prove that these two triangles are actually congruent to each other. So our fifth point is that triangle PQS is congruent to triangle RQS. And the reason we know is because of the angle, side, angle postulate.